Hello, welcome back to Cinderella Math. Today, one of my tutoring students, has sent me in a few questions she needed help on. This is Algebra 2, but you could maybe do this in an Algebra 1 or even a pre-calc. It's kind of just high school math, period. And it's solving quadratics with the specific strategy of complete the square. This is my least favorite way to solve quadratics. Usually I'd rather factor or just do the quadratic formula, but I think my student's teacher in particular wants her to complete the square. So I will be doing that. I'm not going to send up her papers. I'm just going to write it because it's only 3 questions. So that's why I'm calling this a quick take. I may do a more in-depth video on this another day. But for now, here is our first question. I'll just call this example 1. We have x squared plus 10x plus 1 equals 24. All right, so our first step is going to be to move over the constant that is with the trinomial. So we have our trinomial here, and we don't want the constant. So we're going to go ahead and subtract the 1, get off, and subtract 1. That leaves us x squared plus 10x equals 23. So step 1, move the constant if you need to. Step 2, this beginning or leading coefficient needs to be a 1. I'll do the third example when it's not a 1. That's the hardest case. But this one, it is already a 1. If this is already a 1, we are ready to proceed into the completing the square process. Okay, what you want to do is you want to write back down what you have. You don't really need that 1, by the way. You want to write what you have, and you want to give it a blank after that where the constant would be. Keep your equal, keep our 23, and give this a blank as well. And it's always going to be plus blank on both sides. Why do we do it on both sides? Because in algebra, we need to keep our balance. And now, here's the main part that if you don't do this part right, you're toast. You're going to take this middle number, which is known as B, right? This is technically A, this is B. You're going to take him to the side here and cut him in half, just the number. So take 10, cut him in half, so that's 5, and square it. So that's 25. That is going to go in your blank on both sides because we need to keep our balance. This side is just numbers. Add that up. So 23 plus 25 is 48. And this side should factor pretty. If this doesn't factor pretty, then we messed up. That is the purpose of this process, is to get this left-hand side to be a pretty trinomial. So I'm going to magic X factor, you factor, however you know how to factor. I'm going to put a 1. First times the last is 25, and our middle number is 10. Go through your times tables. What multiplies here adds here. 5 times 5. So our factoring would be x plus 5 and x plus 5. We did not cheat because this is a 1. If you're not sure what I'm talking about, look on my channel either on the Algebra 1 or the Algebra 2 playlist and watch my video on factoring, or factoring trinomials. Okay, but look, these are the same. So couldn't we just save time and say this is x plus 5 twice or squared? And it still equals 48. And the directions here were solve. So we want x by itself. Well, I'm going to have to undo this square. I'm going to have to square root, and I'll have to square root this side to be fair. Anytime you square root, don't forget to do a plus or minus. That's just the rule. So now we have x plus 5 equals plus minus root 48. If you push root 48 on the calculator, it's ugly. Let's bring it to the side and see if he breaks down. So we're going to simplify this root, or simplify the radical. So that's what? There's many ways to break down 48. I've thought of 12 times 4, and then I thought of 3 times 4. I look for partners. The partners get married, and they come to the outside. So this is going to be 4 on the outside. He did not get married. Put him back in. Now, your little factor tree could look different than mine, but you should still get 4 square root 3. And this still equals x plus 5. And you should still have the plus minus. Finally, we want x by itself, so we're going to minus 5, and that's going to go in the front because it just looks better. Final answer, x is negative 5 plus or minus 4 root 3. That is solving a quadratic with the complete the square method. It is a mess. I do not recommend it. But my student's teacher wanted her to know this. You could do that with quadratic formula all day long. Okay, so if you know your quadratic formula, do it. Unless your teacher specifically wants this method, I really don't recommend it. Okay, it works. It just takes forever and it's ugly. Okay, so if your teacher's not uptight about the method, you could just use quadratic formula and you would get the same answer. Okay, I'm going on to example 2. We have x squared minus 14x plus 62 equals negative 77. So again, you want to move over the constant from your trinomial. So we're going to minus 62. And we're going to have x squared minus 14x is negative 139. Okay, yay. You want this first leading coefficient to be a 1. It is. And again, in a second, I'll do one where it's not. But this one is a 1, so we're good to start our process. We're going to say x squared minus 14x plus blank, and then negative 139 plus blank to keep your balance. Take your middle number, just the number, so negative 14, chop it in half is negative 7 square. Negative 7 times itself is positive 49. That's why this one's always going to be plus, because anything squared is positive. This is just numbers. Add that together. This is negative 90. And over here, this should factor pretty. Factor however you like. I magic X, I put a 1. We have 49 and negative 14. What multiplies to 49 adds to negative 14. Negative 7 times negative 7, because negative times negative would be positive, but if you owe me 7 plus you owe me 7, you'd owe me 14. So that would be x minus 7, or let's be fancy and say that's x minus 7 squared. And that equals negative 90. But we're solving for x, so we're going to need to square roots and square root. So this is now x minus 7 equals, watch out for that negative. Remember the trick? Whenever you have a negative in a square root, it pops out to be an I. So that's going to be I root 90. Don't forget your plus or minus. Okay, if you're uncertain why that negative is, it's a rule for square root of negatives. You couldn't do it. So a mathematician in the 1500s invented the imaginary I. That's a lesson for another day. All right, if you type in square root 90, it is not pretty. So again, we need to come off to the side and see if 90 breaks down. I'm thinking 9 times 10, which is 3 times 3, partner. And this is 2 times 5, no partners. No partner, there we go. So we would have x minus 7 equals plus or minus 3i, because these 3 got married, so they popped out, and the 10 is not married, so back in. But I want x by itself, so I'm going to add 7, and that goes in front because it just looks prettier. Final answer up here in the pink for room, x is regular 7, because we added it, plus or minus 3i, don't forget the I, root 10. That is solving a quadratic by completing a square, and that in particular has imaginary solutions. Again, do not recommend. You would get that same answer if you just did quadratic formula. So again, if you know quadratic formula and your teacher's not uptight about your method, I would probably do it that way. And here's going to be our final example that my student sent over. This one's going to be the hardest one, so I did hold it for last. This is example 3. 2x squared minus x minus 3 equals 0. Okay, so again, we're going to go ahead and move over the constant from your trinomial. So we'll add 3. So we have 2x squared minus x equals 3 when he comes over. This needs to be a 1. It's not. So we need to pull that out. So basically, you're going to factor out a 2. So pull the 2. So divide this by 2. That's gone and gives you x squared. Divide that by 2. Oops, sorry. Divide that by 2. There's an invisible 1. So that'll be negative half x. Then we can do the blank, still equals 3, and do the blank there to hold your balance. Okay, why did we do that? Why? Because this first leading coefficient must be a 1 for this method. It wasn't a 1, it was a 2. So I had to divide by 2. I had to basically factor out a 2 to make it. Okay? I know, it's annoying. Now that's a 1. So now let's do our middle number thing to figure out what goes in the blank. Take this middle number, so negative half, and cut it in half. So basically you're going to times it a half. So that would be negative quarter and square it. So that's really negative quarter times itself, which would be positive 16th. That's going to go in this blank. Careful. Always we've just put the same number here. Not this time, because technically, if you distributed that 2, that's really 2 times a 16th. I'm doing that off to the side. 2 times a 16th. Well, that would be 2/16, which is an eighth. That's what goes here, because if we distributed this, you would get an eighth. So we need an eighth on the other side to hold the balance. Okay, so we're still going to drop the 2. This should factor pretty, and over here we have 3 and an eighth. Let's turn that to improper. You do 3 times 8, which is 24, and you add 1, and you get 25 eighths. If you have a calculator that does that, go for it. This still will drop down, and let's factor here. So this is 1 times a 16th, so that's a 16th, and negative half. Multiply here, add here. Here's a trick. It's going to be this number that you squared. It's going to be negative quarter, negative quarter. Let's just make sure. If you do negative quarter times negative quarter, you get 1/16. And if you owe me a quarter plus you owe me a quarter, you owe me 2 quarters, which is negative half. So yes, that does work. So our babies would be x minus a quarter, x minus a quarter, but let's get fancy. That's x minus a quarter twice. And then I'm going to put that 2 right there. There we go. Solve for x, but I don't want the 2. So I'm going to times by the reciprocal. Let's times by a half. 2 times a half, that'll cancel. And let's times this by a half. So now we have x minus a quarter squared equals 25/16. Take the square root, because I want that off. Take the square root, take the square root. We get x minus a quarter is plus or minus. Don't forget to plus and minus anytime you do a square root. 5/4. Right? Square root of 25 is 5. Square root of 16 is 4. Move this over. So we'd have x equals a quarter plus or minus 5/4. And then you can just do this arithmetic. Do the plus one. So that would be 6/4, which reduces to 3/2, and then do the minus one, which would be negative 4/4, which is -1. Answers. So the final answers here, x equals 3/2 and -1. Technically, you should put the -1 first. It's fine. It doesn't matter. It's good. All right. Horrific. It's, I don't recommend this method really ever, but I really don't recommend it when this is not a 1, because then it oftentimes gets fractiony. Not all the time, but it can, like this one. Do not recommend. Okay, but if your teacher's uptight and you got to do it that way, there you go. Okay. All right, again, this was a little short on solving quadratics using complete the square. Not a great method. It does work, not my favorite. I hope this was helpful. If it didn't, let me know and I can do another video with some more examples. I hope you're having a great day and I hope to see you soon. Bye bye.